Hi, let me walk you through the single cell BMS algorithm development kit that is done by Decibels lab. As a part of this lab kit, the students will be able to develop an algorithm in the MATLAB and Simulink for a single cell BMS and then get an opportunity to generate the C code and implement the C code into the real-time hardware. As a part of this whole lab kit, it consists of a hardware and also a software. The hardware consists of an option to put a single cell, that is 18650, to start with as a basic configuration. We also have a large size single cell board where you will be able to configure more varieties of cells, maybe 18650, 21700, 26650, or even larger size configurations as well, and of a different chemistries too. Then this board consists of an optional charger. That means you can enable the charging process, and the charge board can take care of the charging a lithium ion single cell. It is passed through a set of MOSFETs and also a current sensing. So henceforth, when you are putting a charger in place, depending upon the charging current, you can control the MOSFET to cut off or allow the charging process to happen. It also has a temperature sensor such that if the temperature during the charging process goes above a specific limit, then the charger can be cut off through a MOSFET as well. Then the other side of the board, we have the load. You can change and vary the load depending upon the number of switches that you turn on. That enables resistors to get turned on, and then that will draw the specific amount of current from the cell. The same process through which the charging goes, the discharging also goes through a MOSFET and a current sensing. That means you're trying to measure the current when the discharging process is happening. So if the discharging current goes above a specific limit, then you can inform the MOSFET to turn off, and that is all done through the software that is written by the learner during the part of the course. The single cell BMS also has an opportunity to measure voltage at the microcontroller. As it is single cell, the voltage would not cross above 4.5 volt or a 5 volt. So hence it makes sure that the voltage measurement can happen directly through a microcontroller. So henceforth, we are measuring a temperature, we are measuring the current, we are measuring the voltage, and we are trying to control the charge cutoff conditions, the discharge cutoff conditions, under voltage conditions, over voltage conditions, and various different scenarios through a single cell BMS. And also students can develop, participants can develop an algorithms such as state of charge, the state of health as well, and implement inside the single cell BMS. The only limitation possibly of a single cell BMS would be that the cell balancing may not be possible as a part of this activity, because there is only one cell that has been put into a kit. So this part of the hardware also consists of a set of LEDs such as that you see here as a part of the board. They will be able to let you know what is the fault condition at which, for example, if there is an overcurrent fault, if there is a over voltage fault, or if there is a BMS on condition, the charge on condition, or also various different type of conditions are enabled through LEDs, so that the learner can see what is the fault condition and what is the state of the BMS which is in the fault condition as well, or working condition as well. This is the part of the hardware that enables a learner to interact and develop an algorithm into it. In addition to that, the whole algorithm that goes into the single cell BMS will be developed through MATLAB, Simulink, and Stateflow platform. As it is interfaced here and visible on the screen, the whole consists of understanding how to use ADCs and protection logics, and also a part of parameter estimation, and also the result logics through which we are able to turn on the LEDs to indicate the conditions in place. Henceforth, through this whole process, first students understand how to develop a software for a single cell BMS, and then they can get this hardware kit through which they can implement the algorithm and then conduct various different number of test cases and enable themselves with a practical learning experience and a real-time understanding and implementation of algorithms into the hardware and controller as well. This gives a learner a confident level, like in a working experience as in industries or in internships or projects, so that they gain a confidence of working with a real-time BMS and also understanding the slight dynamic variations that happens during any of process of charging the BMS or discharging the BMS as well. Henceforth, the learning kit gives you a wonderful opportunity to learn in a practical way and also through a hands-on experience as well. Thank you.